Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 7.4, Problem 3. This is Section 7.4, Problem number 3. It says, consider a normally distributed random variable with a mean of mu equal to 88.24 and a standard deviation of sigma equal to 11.15. Find the following probabilities. So we want to find the probability first that x is greater than or equal to 100. So, again, visually, what are we trying to find? We'll have a normal curve. The mean is the middle value, so there's the 88.24, so 100 is bigger. And so to come to the right of the 88.24 afterwards, and we want to find the probability that it's greater than 100. So what we have to do is find the z-score for 100 and look it up. And then we'll do 1 minus the chart value because it's a greater than question. So we're going to use the formula z equals x minus the mean over the standard deviation. That's the z-score formula. And for part A, the x, the number we want to convert, is 100. Minus the mean is 88.24. And the standard deviation, is 11.15. This one has some decimals in it, makes it seem a little bit messy. Use a calculator. So on top, 100 minus 88.24. I think it's 11.76. Let's make sure on that. 100 minus 88.24 is, yes, 11.76. And in the denominator, 11.15. That's close to 1. It's like 11 over 11, but it doesn't reduce by anything that I can do in my head. So with my calculator, I'll enter the numerator 11.76, divide that by the denominator 11.15, and the calculator will tell me exactly what it is. And it tells me the answer is 1.054708552. So that's my z-score. That's what I want to look up. Now, to look up any z-score, step 1 of the process is write the number to look up so that it has 2 places after the decimal. Well, I got way more than 2 places, so I want to round it off. When I go 2 places out, I'm at the 5. And if I look at the next place over to the right, it's a 4. 4 is not big enough to make it a 1.06, so it just drops at 1.05. That will be my number to look up. So now the next step of the process is write the number with 2 places after the decimal. I did that. Next, pull off the rightmost digit. I'm going to split the number into 2 parts by pulling off the rightmost digit. So the 5 comes off to one side. Then after that, you put a 0.0 in front of the rightmost digit that you pulled off. So now I'm going to look in the positive 1.0 row of the chart. Make sure you pay attention, it's positive. Intersect it with the 0.5 column of the chart, and they will intersect at 0.8531. So now that's the number from the chart. And the number from the chart is telling you the area to the left of what you've looked up. And in this case, that's not what I'm interested in finding. I want the area to the right of. This is a greater than. So I have to do 1 minus the chart value, 1 minus 0.8531, which would be 0.1469. So almost a 15% probability of being in the shaded region of the picture here. So that's A. Now B, what's the probability that x is less than or equal to 70? So again, visually, what am I trying to find? So I have a bell curve. Because it's normally distributed, the graph has to be the bell curve. The mean is the value in the middle, 88.24. I want the probability of being less than 70. 70 is less than the 88.24, so we'll come to the left of it. And I want the probability of being less than that 70. So what I need to do is find the z-score for 70 and then look it up in the chart. Now, because of all the decimals, what I'm going to do, instead of using too much space on the board, is make a little room underneath. So now I'm going to use my z-score formula for the 70. So z equals x, the number to convert to a z-score is 70, minus the mean is still 88.24, over the standard deviation is still 11.15. So now I want to do the math. Again, I have some messy decimals. The top should be pretty easy. It looks like it should be negative 18.24, but the calculator will make sure of that. The top is, for sure, negative 18.24. And then the denominator, 11.15. Now again, that does not reduce easily, but the calculator will do it very easily. So I would have the numerator, negative 18.24, don't forget the negative, divide by the denominator, 11.15, equals, and the calculator does that like no problem. And the calculator tells me it is negative 1.6358744439. That's the z-score, a lot of decimals. But when we look it up, step one of the process is to write the number to look up so that it has two places after the decimal. So if I go two places out, I'm at the 3. The next digit to the right of that 3 is a 5, which is big enough to make it a 4. So the number to look up will be negative 1.64. That's writing it so that it has two places after the decimal. The step after that is to split the number into two parts by pulling off the rightmost digit. So I'll have a negative 1.6. The 4 gets pulled off to the side. After that, you put a 0.0 in front of the rightmost digit that you pulled off. So now when I go to the chart, I'm going to go to the negative 1.64 row. And then you're going to look in the 0, 4 column, negative 1.6 row, the 0, 4 column, intersect those. They will intersect at 0.0505. That's the number from the chart. Because this is a less than question, the number from the chart is the answer. That shaded area is 0.505. So in terms of percents, if you like your probability as a percent, it's about a 5% probability of being in the shaded region of the graph that I drew. Now, part C is an in-between. That's the most work. It's kind of like doing two problems at once. What's the probability that 50 is less than or equal to x is less than or equal to 60? So in other words, what's the probability that x is between 50 and 60? I have to find the z-score for 50, look that up. Find the z-score for 60, look that up. And subtract the two answers that I get. And again, visually what's going on, I'll have a bell curve. The value in the middle is whatever the question tells you is the mean, 88.24. And now 50 and 60 are both smaller than that 88.24, so they will be to the left of it. So I have kind of a narrow little bit of area. So again, by my graph, which I know is not to scale, I would expect like a single-digit probability sort of an answer. So let's start the process. Let's find the z-score for 50. And again, instead of writing too small or going all over the board, what I'm going to do is just make some room right next to where I'm working. I'll leave the z-score formula because I'll need it. So z equals x, the number that I need to convert, 50, minus the mean, 88.24. And we have the standard deviation in the denominator, 11.15. So now again, we have some decimals here. We'll want to use the calculator for that. In the numerator, it should be a negative 38.24. It takes only a second to verify that on my calculator. 50 minus 88.24 equals, and indeed it is, negative 38.24. Denominator, I still have 11.15. Again, very difficult to do that in your head. Just use the calculator. So do the numerator, negative 38.24, divide by the denominator, 11.15 equals, and the calculator does it so easily. And the calculator tells me that the answer to that division, when I reduce that, is negative 3.429596413. So that's my z-score. That's what I have to look up. So I look up any number in the chart. Step one is to write the number to look up so that it has two places after the decimal. So if you go two places out after the decimal, you have a 2. The next digit to the right is a 9, which is certainly big enough to make it a 3.43. So what I want to look up is negative 3.43. Now I have it written so that it has two places after the decimal. After that, I want to split it into two parts by pulling off the rightmost digit. So when I pull off the rightmost digit, the two parts, one part will be negative 3.4, the other part will be a 3 when I've removed the rightmost digit. After that, you put a 0.0 in front of the rightmost digit that you pulled off. So instead of a 3, it's a 0.03. Now I go to the standard normal chart, get myself into the negative 3.4 row. That's the top row of the negative part of the chart. Follow it out until I'm under the 0.3, and I have 0.0003. So very small probability. So that's the chart value for the 50. So I have to do the same process now for the 60, and I'm going to subtract the two values. So let me make a little bit of room, convert the 60, and in fact, let me only erase a little bit of it because what do I have to do? X minus the mean over the standard deviation. The only thing that changes is the x. It was 50 before. So to do the other part now, it's 60. Right? The minus is still a minus. The mean is still 88.24. And the standard deviation is still 11.15. So I'll change what was a 50 to a 60, and now I'll do the math. And again, the top seems reasonably easy. It should be negative 28.24. I'll verify that with the calculator. On the bottom, 11.15. So just double check the top. 60 minus 88.24, sure enough, is negative 28.24. And I want to divide it by 11.15. Not easy to do in your head. So I will use the calculator. The top, or numerator, negative 28.24, divide by the denominator, positive 11.15. And when I do that division, the calculator tells me that the answer is negative 2.532735.426. That's the number I need to look up in the chart. So to look up a number in the chart, step one is write the number so that it has two places after the decimal. So when I go two places after the decimal, I have a 3. The next digit to the right is a 2, which is not big enough to make it a 5-4. So since it's only a 2, everything that comes after that second place out gets cut off. So the number I need to look up written so that it has two places after the decimal is negative 2.53. Again, very important that you don't lose the negative. Now that I have it written so that it has two places after the decimal, next you split the number into two parts by pulling off the rightmost digit. So I have negative 2.5. Take the 3, pull it off to one side. Now I have the number written in two parts. Next, put a 0.0 in front of the rightmost digit that you pulled off. So I pulled off a 3 as the rightmost digit. I now write it as a 0.03. Now I go to the negative 2.5 row of the chart. Again, make sure you know that it's negative. The 0.3 column, and where you intersect those will be 0.0057. Still a pretty small probability. So that's the value for the 60. I wrote the other one underneath. Let's be consistent. 0.057. So because it's an in-between question, I have my two chart values. Now I'm going to subtract them. And again, you must subtract in an order that gives you a positive result. The result you're finding is a probability, so it has to be positive. You can't have negative probability. So I'll have the larger value, 0.0057, minus the smaller value, 0.0003, and that's a very easy subtraction to do, at 0.0054. So it's about a 0.5% probability, if you like it in terms of percent, 0.0054. And finally, part D. D is actually the very easiest. Find the probability that x is exactly equal to 64. These types of problems, if it's an equal to, like part D, I don't have to really use the chart or the z-score formula or anything. I know the answer is 0 right away.